So this is a variant of the last question, a little bit different but similar sounding. It says, suppose that there are two different trucks moving with an equal amount of momentum. If one truck is lighter than the other truck in the sense that it has less mass, which truck has more kinetic energy, the lighter or the heavier truck? So I said it's the same as the last question, but it's different in one aspect. In the last question, before this one, we had the kinetic energy the same for the two trucks, but now we're saying the amount of momentum is the same for the two trucks. I have the two formulas here, so one could look at those and maybe say like, okay, well, keeping momentum the same, what impact is that going to have on kinetic energy? And maybe conclude that the lighter truck is the correct answer. I mean, isn't that obvious, right? Well, if it's not, use the table method. This is a pretty cool method, I think. And for this one, I think the numbers are going to be pretty straightforward, I believe. Oops, I had the wrong pen marked there. Let me get the correct pen setting. So I'm going to start with the heavy truck with 2 and 1 sort of arbitrary numbers. And, I think the last one I didn't say, like, what units am I using there? And I don't care. This could be in, like, tons and I don't know if miles per hour makes sense there, but it'd be going really slow, right? It doesn't really matter, though. This is just to get the idea and try to answer this question. And picking simple numbers is an easy trick for doing that. So if the heavy truck has mass 2 and velocity 1, then let me see. It'd be 1/2 times 2 times 1 squared. So I think the kinetic energy would just be 1 in this case. But the momentum would be 2 times 1 is 2. Now we're going to go to a lighter truck, and I'm again playing kind of similar games I did in the last example. I'm just going to drop the mass by half, so 2 goes down to 1. In order to keep the total amount of momentum the same, though, I'm going to have to, in this case, bump up the velocity by 2, right? Because since momentum is just these two multiplied, that means that those two clearly have to be the same. And to answer the question, because we're being asked, right, which one has more kinetic energy, we can now use these two numbers to calculate kinetic energy. And since this is the one I'm maybe most interested in, I'm going to actually put in the numbers here following the formula of 1/2 mv squared, right? So that would look like this, right? It would be 1/2 times 1 times 2 squared, which 2 squared is 4. We can ignore that 1, and half of that is 2. So I think that's 2. So that means the light truck indeed has the larger amount of kinetic energy. And even though these were simple numbers that make it easy for me to do calculations and really see how the result relates to these formulas, even if in reality I had two trucks where maybe their mass differed only by 5 or 10% or whatever, the overall result would hold. If they both have the same amount of momentum, the faster moving light truck would have to have more kinetic energy. And again, that kind of makes sense because the gained speed for the light truck is more impactful towards kinetic energy, so hence it's going to have more of it. So there's the answer, the lighter truck.